Good morning. Or actually, it's technically afternoon, so thank you for giving up some of your lunch time to spend some time with us today. We're going to make it productive time for you. So, my name is Rich Mason. I'm the GM of the MySQL team here at Oracle. With me, I'm going to have several people up on stage today, but we're going to have Thomas Ulin, who's Vice President of MySQL Engineering. Thomas is down the front here, and also Nipun Agarwal, who's Vice President in Oracle Labs. And we also have the pleasure of two MySQL customers joining us this afternoon. We're going to have Kenichi Sasaki from Mercari in Japan, Japan's largest community-powered marketplace, and they have 10 billion in monthly transactions, so a lot of volume with MySQL. And then we're going to have Rich Steenberg from WePay, a leader in digital payments, and also a subsidiary of JP Morgan Chase. So we have an interesting and varied afternoon for you. Okay, before I get started, I'm not sure whether you can actually read that, but I'll just give you a few minutes to look at the eye chart. All right, okay. So as I said, we've got lots to cover. We're going to look at the momentum behind MySQL and some of the developments in the pipeline that are really just around the corner. We'll cover security with MySQL, a very big topic these days. And then Thomas and then Nipun will look at MySQL 8.0, the MySQL Cloud Service, the second generation MySQL Cloud Service that's currently in testing, and then our new MySQL Analytics Service that's also in testing. And then you'll see more detail from Thomas and Nipun and some of our customers as we go through that. MySQL continues to be almost everywhere. DB Engines, you may have seen this, we've presented this on several years. DB Engines ranks more than 300 database systems according to their popularity from a variety of online sources. And this data is aggregated and stack ranked every month. They look at the number of mentions that the database system has on Google and Bing. They use Google Trends to measure the general interest in the database. And they look at the frequency of technical discussions about the database, and they get that from Stack Overflow and DBA Stack Exchange. The number of job offers in which the database is mentioned, and that data comes from Indeed and Simply Hired. And then they look at LinkedIn data to measure the number of profiles in professional networks in which the database system is mentioned. And all that data is aggregated and stack ranked into a league table every month. And as you can see from the chart, MySQL is the second most popular database in the world after Oracle DB, being number one. MySQL is more popular than Microsoft SQL Server, and it is the most popular open source database. And over the last 5 years, MySQL has consistently been in the top 3 every month. The reason that MySQL is so popular is that it performs, it scales, it's easy to use, and as some of our customers say, it just works. Other surveys show similar results. Stack Overflow, they have an annual survey, and it's the largest, most comprehensive survey of developers around the world. In this year, 2019, they surveyed 9,000 developers, and it showed that MySQL was the most popular database for developers. In fact, for the last 3 years, since 2017, when Stack Overflow added surveying about the database usage, MySQL has always been the most used database by developers in their survey. Now, the amount of data that organizations have to manage now is colossal. According to IDC, the sum of the world's data, or the data sphere, will grow from 33 zettabytes last year, 2018, to a mind-boggling 175 zettabytes by 2025. And as a point of reference, that forecast of 175 is almost 10% higher than their forecast this time last year. The report contained a couple of eye-opening findings about the projected growth. There's going to be yet more internet users. There's going to be 4.8 billion internet users by 2022. And that's up from 3.4 billion in 2017. There's going to be more devices. 10 billion new devices will come online over the next 5 years. 49% of that data will be stored in public cloud environments, and nearly 30% of the data generated will be consumed in real time. So this data growth is going to put some significant demands on data management systems and the people needed to manage them, particularly around the area of security. It's easy to argue that in today's digital world, that data is your organization's most single valuable asset. Whether it's about your customers, partners, or employees, about your intellectual property, your M&A, strategy, or sales figures, some data has a short lifespan. Some data has a lifespan of several decades. Some of it's generated by you, such as your orders, while some is actually trusted to you by others. Personally identifiable information, payment card data, personal health information data. And your data is so valuable that others want it too. Identity thieves, state-sponsored criminals, malicious insiders, they want your data. Despite all the new data privacy laws and industry regulations, mega breaches involving millions of compromised records continue to make headlines. I'm sure you've seen some of these before. In fact, in the first 6 months of this year, calendar year 2019, there have been more than 3,800 breaches and 4 billion records stolen. 2 months ago, personal information of 100 million Capital One customers and their applicants was stolen. It included social security and bank account numbers. The CEO had to give a public apology. And Capital One may yet face hundreds of millions of dollars worth of fines. Marriott, personal information of 500 million guests was compromised. The information accessed included payment information, names, mailing addresses, phone numbers, email IDs, and passport numbers. Marriott faces a fine of $124 million for failing to protect their customers' data under the GDPR regulation. British Airways, this is an old one, it actually happened last year, but there's been a new development. British Airways said that names, addresses, email IDs, and payment card details from 380,000 transactions from last summer were all compromised. This is personal to me. I live in the UK. I travel a lot with BA. I can tell you being on the receiving end of the fallout of that was not pretty. It resulted in them asking me to cancel my credit card and some other things along the way. Not good. 3 months ago, the UK government announced that BA will be fined £183 million, which is around 1.5% of their annual revenue. The attackers are getting more sophisticated. The attacks are getting more frequent, and these fines are escalating. Amongst all this, CIOs really have the hardest C-level jobs. Technology has become the backbone to organizations' efficiency, their communication, security, and we've just heard, their profitability. Security is the top investment priority for CIOs in 2019, and security roles are amongst the hardest to find. 30% of CIOs say they are struggling to find talent in the important area of security. There's over 100 countries now that have adopted data protection laws. There's too many to list on this slide, but in addition, there's some other industry regulations like PCI and HIPAA to concern ourselves with. These data protection laws combine both data privacy and data security. Data privacy controls the collection, the use, and the dissemination of personal information, while data security defines how to protect personal information from unauthorized use or access. Now, historically, many laws have addressed these issues separately, but more recent data protection initiatives are combining privacy and security into unified legislative schemes. For example, the GDPR is a wide-ranging data protection regulatory scheme that has served as a model for other jurisdictions around the world developing their own data protection policy. The GDPR includes data privacy rights, data security standards, data breach notification requirements, and fines for failing to comply. As you can imagine, putting yourself in the CIO's hot seat, trying to comply with this ever-changing patchwork of laws and regulations can be very challenging. So let's look at 2 or 3 scenarios. Let's look at a situation of an e-commerce startup in California, selling goods and services to EU residents. Regions of business, Europe, California, and likely some other states in the US. California has created a comprehensive data protection act called the California Consumer Protection Act, the CCPA. And that goes into effect in just 3 months' time, January 2020. In fact, almost every state has now created its own consumer protection law. So this company would have to comply with GDPR in Europe, CCPA in California, and the PCI DSS for credit card transaction security. Second use case. Now, in the healthcare sector, healthcare providers, including doctors, clinics, hospitals, as well as health insurance companies, must comply with HIPAA. If you're not familiar with it and you're not in the US, HIPAA is a federal law that protects personal healthcare information. So HIPAA includes a privacy rule, defines how health information can be used or disclosed, a security rule, which is technical safeguards around encryption and data access, then a breach notification rule. It requires organizations to notify affected individuals, the Health and Human Services Department, and in some cases, the media. And then third use case, government agency. In the US, at the local, state, and federal levels, organizations got to comply with a whole variety of privacy and security standards. STIG. DoD orgs in the US must comply with STIG configuration standards. The STIG specify how IT assets should be configured to be secure. In the case of database, this includes authorizing accounts and privilege management. NIST provides the standards for protecting data at federal agencies. NIST guidelines also helps agencies meet specific requirements, such as HIPAA. FIPS defines a set of standards around encryption and cryptography for use within non-military government agencies. And then FedRAMP is a government-wide program that provides a set of security standards for cloud products and services. So let's look at 5 steps, how we can become compliant. Even though the many data protection laws and industry regulations are separate laws, thank goodness they all share some common requirements. So let's look at those 5 steps and how MySQL Enterprise Edition can help you protect your sensitive data and of course, be compliant. Number 1, assess security risks and restrict access to sensitive data. Grant access only to those with a need-to-know basis and authenticate users with strong passwords. Protect development and test data. Organizations can reduce the risk of a data breach by masking sensitive or confidential data so it can be used in non-production systems. Encrypt sensitive data. Implement a mechanism to encrypt your data so if data is stolen, it can't be read. And then detect database activity. Organizations must be able to detect and stop malicious database activity. In the case of a breach, a company must be able to determine what information was accessed and by whom, and then is legally required to notify regulators and users around what information was stolen. So how can MySQL Enterprise Edition help? Well, for assessing the potential security risk, MySQL Enterprise Monitor, or MEM as we call it, provides hundreds of best practice advisors alerting you to potential security issues such as weak configurations and overprivileged accounts. MySQL Enterprise Authentication enables organizations to centrally manage and authenticate their users and leverage existing security rules and processes. MySQL Enterprise Masking replicates real values with realistic but fictitious values, allowing production data to be safely used for development, testing, and analysis, or shared with business partners for non-production purposes. For example, HIPAA specifies that PHI data must be de-identified before it can be shared. So masking would allow you to do that. Additionally, MySQL Enterprise Backup, or MEB as we call it, ensures that you can recover your stolen data in the event of a breach. MySQL Enterprise TDE, or Transparent Data Encryption, and MySQL Enterprise Encryption enables you to encrypt your data both at rest and in motion. It's surprising, really, that out of all the billions of records lost or stolen or compromised, only a very small percentage of them were actually encrypted. Encryption, including encrypted backups, are an absolute must to make your data unreadable. MySQL Enterprise Firewall protects your data by monitoring and blocking unauthorized database activity. All queries are matched against an approved whitelist of SQL statements and then blocked if they don't match those expected statements. Also, security regulations have strict rules about notifying regulators and users in the event of a breach. To meet these demands, MySQL Enterprise Audit helps you to produce an audit trail so you can track who accessed what and when. So MySQL Enterprise Edition can really help you get to grips with a lot of these requirements and the need to be compliant. I'm going to change track just for a second. In June this year, Gartner published a research report called The Future of the Database Market is Cloud. They had some interesting numbers in this report. The overall database market is growing, and it grew to $46 billion in 2018. $10 billion of that $46 billion is from database cloud services. The overall database market grew at 18% from 17 to 18. That's the fastest growth of this market in over a decade. And cloud database accounted for 68% of that growth. So the evidence is pretty clear. The vast majority of organizations, big and small, will be using the cloud in increasing amounts. So I'm just going to introduce two cloud services that we have in development right now. In fact, they're in testing, and you'll hear more about them shortly, but I just want to introduce them from a very high level. MySQL as a service, this is our second generation MySQL cloud service, enables you to really cost effectively deploy modern applications using MySQL in Oracle's cloud. Think of it as the union of OCI, Oracle Cloud Infrastructure, and MySQL Enterprise Edition. MySQL is built on the second generation of OCI, so that's Oracle's bare metal infrastructure as a service. And it's capable of running traditional multi-tier enterprise applications, high-performance workloads, and modern serverless and container-based architectures. With MySQL as a service, it's a managed service, it's simple to provision a database with just a few clicks. It automates most admin tasks. It's integrated with other OCI services for quick development and deployment. And it's enterprise-ready with MySQL Enterprise Edition features, management tools, and 24/7 MyOracle support. Because MySQL is developed at Oracle, it's the only public cloud service that offers MySQL Enterprise Edition as a service. So whether you're a developer, an ISV, or an enterprise, you can all rely on MySQL as a service because it allows you to rapidly, cost-effectively, and securely deploy modern applications. And the important thing for me is it's powered by MySQL, but with the backing of Oracle. Just talk very quickly about the analytics service that Nipun will cover shortly. This is a result of a collaboration with Oracle Labs, who've invested hundreds of person-years of work in this technology space. As I said earlier on, it's in testing phase right now. With this service, users can run analytics on the same data which is stored in MySQL for transaction processing. There is no time-consuming, complex export or reload required. It's designed from the ground up to support in-memory SQL analytic processing, and it's architected for massive scalability, literally hundreds of nodes. And we're optimizing it for OCI. We expect, in fact, we already are seeing, because I said we are doing testing, and you'll hear more about this, we're already seeing that our customers' applications will achieve compelling performance per dollar improvements for their analytic workloads. And since I have the opportunity, if anybody here wants to get involved with this and become a beta tester in some of these services, please approach us. We'd love to collaborate with you. So I think my time this afternoon is finished, and I think it's time to introduce Thomas. Thomas, come up on stage, please.
Thank you. Handshake. Thank you, Rich. Okay, so I realized coming in on the airplane the other day that this is the 10th time that I'm at Oracle Open World presenting news about MySQL at Oracle. And I'm very proud of what we've achieved with MySQL at Oracle over these years. I've been now with the MySQL team for about 16 years. And I must say we've done huge progress with MySQL over these last 10 years. One of the things that we set out early on joining Oracle, where would we invest more moving forward? And quality and QA was one of the areas that we decided this is where we're going to invest a lot. And I think you can see over the course of the releases that we've had since 5.5 then and moving forward now to 8, you can see really how the quality has improved as a result of that decision early on. I think in MySQL 8 also, which is, I'm proud of all our releases, but I'm really proud of 8 and all the innovation that we brought into 8. I'll be touching on those shortly. So MySQL 8 is, as you understand, our latest GA release. There's not enough time to go through everything. I mean, there are talks during the week here that I encourage you to join to dig into the different details. I'll just bring out 4 highlights of MySQL 8 here that I think sort of shows the innovation that we brought into MySQL 8 and one of the reasons why I'm so proud of this release. So first of all, it's a MySQL document store. It's MySQL InnoDB cluster, MySQL security that Rich has talked about plenty already, and there's also MySQL shell. So with MySQL 8, we're being widely recognized as being very full features when it comes to SQL. And you can see in this survey here and the comparison that they've done that MySQL ticks in all the boxes on the different SQL features that people are looking for. The other thing which is happening with MySQL 8 is we're seeing, and I see part of it is because of the high quality that we've reached over time, very fast adoption for MySQL 8. So we GA'd MySQL 8 a little over 1 year ago in April. With about 5% of our downloads were MySQL 8 at that point in time, and we reached over 25% in a little over a year. And that's comparing to previous releases, by far the fastest adoption that we've seen of a release. I mentioned quality. I mentioned the highlights that we have. Those are 2 things that, of course, drives adoption. Another thing that we've done with MySQL 8 is introduced the upgrade checker. People are always worried when there's a new release, will there be issues? And of course, if there are issues, it hits them unaware. So with the upgrade checker, which is a very quick and easy shell utility to use, you run it and then you can identify issues based on severity, and it can also recommend fixes. So I encourage you, if you're not there already, to run the upgrade checker and see where you are, and then you can plan for how you can mitigate those things that might be issues, and then plan your upgrade to 8. There's so many good things in there. So coming to one of the highlights, MySQL document store. It's where we bring SQL and NoSQL together. If you've been to our booth, you can see the little stickers that we have, SQL plus NoSQL. And we've had tremendous, great feedback on this, on these capabilities. And what we also added to MySQL 8 to further this store is a specially developed, what we call XDev API. So with MySQL Document Store, you get a document-oriented data storage with MySQL. You have JSON document support. You can use it like you've done traditionally through SQL and add schemaless data to that to it through JSON objects, or you can come from sort of I don't know any SQL at all and start using MySQL, develop against MySQL through the XDev API, and not having to touch one line of SQL code. And then you can mix and match between these two. So you can mix schemaless and schema-based data in the same. You can do rapid prototyping with very simple CRUD APIs. And then, of course, we have the strong connector support that MySQL always have had, the wide range of connectors. And to help you there, we have MySQL Shell. And I think when we initially built MySQL Shell, we had a few ideas of why we were doing this new shell. But we realized over the course of the years that we have been releasing this, that this is just a tool that people love. And we've expanded it, added more and more features, and we will continue to add more features into the MySQL Shell. It's such a versatile tool. So you can do anything from rapid prototyping. You have the full XDev API support. You can run JavaScript, Python there directly in the shell. Full SQL support. You have built-in auto-completion as well, very powerful. And one thing that I'll touch on in a minute, you also have the InnoDB cluster support. Doing InnoDB cluster and doing HA with the shell is so easy. I encourage you to join one of the sessions that talks about this, and you'll just see how easy it is to work with the shell. And it's also a DevOps tool. You can do so many things here, and there are more things coming down the line in the shell that I hope to talk to you about at some later point in time. I talked about the strong SQL support that we have. Just highlight two of the ones that we've received a lot of attention around. That's the common table expressions, or CTEs, and window functions. Very, very powerful SQL constructs. And as I said, has been very well received by the community and our customers. We continue to improve 8. We're being very agile. We listen to customers, users, and we continue to develop 8.0 and add things that are requested frequently. Hash joins is such a thing that is a powerful way to join data. It's not always that we have our nested loop joins, especially for inner equi-joins, where hash joins will be invoked automatically, and you get dramatic speed improvements. You can also use hints and so on to force one join algorithm or another. So this is new in 8.0.18, which is coming out in a month or so. Also 8.0.18 on popular request is explain analyze. So explain analyze will run the query, but it will also instrument the query as you run it, and you will see estimated costs. You will say actual execution statistics, time to return first row, time to return all rows, number of rows, etc., etc. And it uses the new tree output format that we have, which is also available in Explain. So coming to InnoDB cluster, which I think innovation-wise is probably the biggest in 8. We had an early release of InnoDB cluster in 5.7, and maybe you've been using it, but we've furthered it even more in 8. And it's really native HA for MySQL. For those of you who have been around for a while, know that if you want to code HA with MySQL, it can be quite cumbersome. But here it's built in. It's based on a few technologies, which is the group replication technology, the router technology that we have, and also MySQL Shell for really easy setup and administration. So what MySQL group replication gives you is the high availability component, elasticity, it's fault tolerant, self-healing. You have everything within that group replication protocol running between multiple servers. MySQL routerage is what helps the clients to connect to the right server in the cluster, handling load balancing and failover and such things. InnoDB cluster is, of course, also being improved over time, and something which is fairly new in InnoDB cluster is configurable cluster-wide consistency levels. In the earlier releases, there was one way in which consensus was reached in the system around committing a transaction to the cluster. Now you can really tailor the consistency level and the way transactions are being committed into the cluster to the business needs or the business logic that you have in the system, right? You can also tune it to where you are willing to take performance impact and not. So, for example, a typical case would be that you commit something into to your cluster, and if you were quick and reading it from a different node, you could read a state which was prior to the initial node that you committed to, which can work fine for certain types of application, but works not so great for other types of applications. And now you can configure this, saying, okay, I want to read my own writes, basically. But there's also a choice there, whether you take the impact on write, in the sense that, okay, I wait for the write to have been propagated to all the nodes, then I take a cost at the time of the write. Or it might be I want to take the cost on the read. I'd say, okay, I write quickly, but then when I read, I actually wait with doing the read until I actually have distributed and reading what I just wrote into the database. So those are choices that you can make. You can do these cluster-wide, but you can also do it on a per session basis. So you can choose if there are particular types of data that needs to be distributed into the cluster in a specific way. So very powerful, a lot of different ways in which you can choose. I've just mentioned a few of them, but there are a lot of details into how this protocol works and the different types of consistency levels that you can choose to operate under. Something which is new as of the last release, 8.0.17, is the clone plugin, which is automatic node provisioning within a DB cluster. It's become even easier now to just add a new node to the system. It is as simple as a command, basically, to have a new node join the system. The data will be automatically propagated over to that node. All the states and so on will be handled when the node is made available in the cluster, and so on. And should you have a situation where one node leaves the cluster for some reason, maybe there's a network glitch or something, it's voted out, and it rejoins again, it's even so smart so it can decide whether it's better to reclone if it's been away for a long time and there's a lot of activities been going on, or whether you just fetch the delta from when it left. So very, very powerful, and the initial feedback that we have on this have been fantastic. And I want to thank Simon, for example, who has been blogging a bit about the clone plugin. Much asked for, and it is here, and I hope you take advantage of this technology as soon as possible. Available with 8, as I said. What we also have, which has been around for many years, known very well to some people, known less well to others, is maybe confusing in the name, MySQL NDB cluster, a technology which was initially targeted towards very, very high-end customers, especially in the telco industry. We used to call it carrier grade edition to target that industry specifically. But over the years, we've seen a broader adoption throughout our user base. So we see it in payment systems, finance systems, and so on. And if you're looking for that real-time, highly available, highly scalable system, this is a technology that I encourage you to take a look at. And the 8.0 hasn't been available. There's been a lot of work going on into bringing also cluster onto 8, and with 8 or 18 we will have it as a release candidate. And some things that we have done on request, especially from the finance side of things, they want to support more than 2 replicas. So a typical NDB cluster setup, you would have data replicated twice, so you could handle a single failure in that node group. But they want it even more secure, so you can actually have 3 or 4 replicas, so you're even more fault tolerant. We've also increased the capacity that we have on the disk data side, faster, more robust. Also bigger data sets overall, more data nodes. Previously we had a limit of, I believe, 48, and now we can go up to over 100 on that. So just overall increased demand in terms of data size, in terms of scale out. So these are some of the things that we've added to NDB cluster. So coming on to Enterprise Edition, I think this is the full picture of what's provided within the Enterprise Edition. So we have our support team there. We have a bunch of management tools, and then we have a bunch of advanced features around scalability and availability and all the security features that Rich has mentioned already. On the management tools, we have a migration tool as well that can help you to migrate from a SQL server into MySQL, for example. So I think most of these have been mentioned by Rich already. So the enterprise masking, the transparent data encryption, authentication, encryption, firewall, audit, monitoring, backup, all of these things to enable us to give you a tool to manage all these 5 steps that Rich talked about. I'm going to highlight a few of these. One thing that Rich didn't have a chance to mention was around how do you manage keys in this secure setup, which is of course a very, very important thing. A new thing that we've added there to MySQL Keyring is the HashiCorp Vault support. And of course we support Oracle Key Vault and other KMIP standard key vaults. And this is about how do you secure your keys, which is a key component in this secure environment. A little bit more about data masking. Rich mentioned one way, and anonymizing data, but you have a bunch of options here basically on how you can do data masking. You can use random number generators, and you can do string matches and masking and so on, dictionary replacement. There are a bunch of different ways in which you can handle and mask data. So it really depends on what kind of data it is there. And very important, as Rich mentioned there, requirement in many of these regulations is that if you want to use something for dev test, which of course everybody does, you need to protect this kind of data, confidential data. You cannot go with that outside a very limited group of people or limited places within the data management system. Okay, over to MySQL as a service. So as Rich mentioned, this is something which is developed and operated by the MySQL engineering team. Of course, that doesn't happen anywhere else. Based on MySQL Enterprise Edition, so you get all the goodies around InnoDB cluster, all the document store, JSON support, and then of course everything that we talked about on the security side here, and supported by our fantastic support team as well. Built on Oracle Cloud Infrastructure Gen 2, and also Nipun will be talking about the MySQL Analytics service, which is something which is totally unique for our service. So what is the cloud service? So just to make it clear, this is a fully managed MySQL service. You should be focusing on your responsibility, the modeling of your data, defining data access and retention policies and so on, all about the data side of things. We take care of anything that has to do with backup and recovery, high availability, failover, scaling, database and OS patching, monitoring, log handling, and so on. When it comes to elasticity and high availability, we utilize the Oracle Cloud infrastructure, which has availability domains. We make sure that the nodes that are being used to achieve high availability are across different availability domains, so we can handle an outage of an availability domain. We handle the failover transparently for you in terms of IP failover, such that the client will not have to do anything specific to failover to the backup MySQL. And also you can add read-only replicas here for horizontal scalability. So all of this is cloud native to give an OCI customer a unified experience throughout the OCI platform. When it comes to the web console, the monitoring, notification, logging, everything happens in a common framework, common look and feel, auditing, how you handle identity, cost tracking, and so on. Right, and the APIs to manage MySQL here or access MySQL, this is all the way everything else is being managed within the OCI framework. So you get a Java SDK, you get a Python SDK with APIs that also can handle the MySQL service and so on. So very excited to have our customers now in beta, as Rich mentioned. We're getting very positive feedback so far, especially on our analytics service. So with that, I'd like to hand over to Nipun to dive into the details of our analytics service. Thank you very much.
Thank you, Thomas.
Handshake too.
Thank you. Thank you, Thomas. Hi, everyone. I'm Nipun Agarwal. I'm Vice President in Oracle Labs. As a part of our mission in Oracle Labs, we do two things. One is we work on projects which are of research nature. And secondly, if the research pans out, we work on ways to transfer the technology so that this research can benefit our customers. And today I'm going to be talking about one such project. MySQL is the most popular open source database. And it has been designed and architected to be very efficient for transaction processing. However, when customers want to run analytics on MySQL, they have to take the data out of MySQL into some other database. The database could be on-prem or it could be in the cloud. So the first thing is there is data migration involved from the MySQL database to some other database. Second thing is you end up with two databases, MySQL, which is very efficient for transaction processing, and this other database for analytics. And as a result of that, if there are any changes which are being made to the MySQL database or for the OLTP database, those changes are not reflected when you run queries on your analytic database until such time that you have the next migration of data, right? So what this lacks, this environment, is support for real-time analytics. So data movement, the need to manage two databases, and the fact that your changes are not reflected in the analytics system. A few years back in Oracle Labs, we started working on a project called Project Rapid, which stands for Rapid Analytic Processing in DRAM, with the objective of building the world's fastest system for SQL analytics. And when I say system, I mean hardware, software, code design. We came up with an architecture like this, which is illustrating that the traditional database processing is being done on a small number of heavyweight nodes. But all the analytic computation is pushed down to this massive number in a scale-out manner of lightweight nodes. In order to achieve the performance which we were desiring, there were four things which had to happen. First, the ability to partition this analytic data across this large number of nodes. Second, The database should be able to push down the analytic operations and analytic operations alone to this large number of nodes. Third, the ability to execute very efficiently these analytic operators, right? So you have things like scans, group bys, joins. We had to come up with new efficient algorithms for in-memory processing. And last, and perhaps the most important, writes software which can scale to this massive number of nodes. This is something which is probably by far the most challenging. So we delivered a prototype system which was significantly faster for analytics than any other commercial available system. So this brought us to the next step of the mission which I was saying. So we did research, we came up with the world's fastest system for SQL analytics, and now we had to see how can we transfer this technology so that it can benefit our customers. When we started working on it, in addition to performance, we threw in another factor, which is we wanted to deliver a system which is not only very performant, but it is also very cost effective. So we wanted to deliver a system which would provide very compelling performance per dollar for SQL analytics. There are two things which we did in the architecture which I just showed. The first is we decided to have MySQL database as the backend. And the reason for doing that is the MySQL database is very efficient with respect to resource utilization. The second thing is we decided to run the rapid nodes, or this massive scale that I was talking about, on the Oracle Cloud infrastructure. So when you're building a system for in-memory analytics, the biggest cost of the system is actually the DRAM. So we picked a shape in Oracle Cloud infrastructure which provides the best price per gigabyte of DRAM, right? So DRAM is the biggest cost of a system for in-memory analytics, and we chose a shape which is the most compelling with respect to price per gigabyte of DRAM. The second thing which we did is we optimized our software for providing very good optimizations for memory, compute, storage, and network bandwidth for this shape, right? So we have done a whole bunch of optimizations in all of these 4 areas. As a result, we now have a system which provides very compelling performance per dollar for SQL analytics. Not just that, our scale factor is so good that as you add more nodes, as you have more data, the performance per dollar only gets better. And that's a very good thing to have, right? So you start small, you have a good performance per dollar comparison, and as you add more data, since we scale very well, and since we scale much better than most of the systems, our performance per dollar proposition only gets better as you add more data. This service is now available in beta or pre-LA, so if you're interested, we welcome your feedback, and we would love to collaborate with you folks. There are 2 main areas where we did integration of Rapid with the MySQL engine. The first is with the query processing engine. We have enhanced the MySQL optimizer so that when a query comes in, and user queries are unaltered, there is no change to the user query. When a query comes in, the MySQL optimizer determines if that query or if the analytic construct can be supported by the Rapid engine. If the construct can be supported, it is sent to the Rapid engine where it is executed. If that construct is not supported by the Rapid engine, then the query is executed as is by the MySQL engine. So the benefit the customers see is that they have an application which is currently running on MySQL 8.0. When you add in Rapid or when you add in the MySQL Analytics service, either the performance remains the same if it is executed by the MySQL engine, or the performance gets better, right? So there is no change to the application, and there should not be any regression to the application, right? So that's the first integration we did. The big benefit of this is all existing applications and tools which work on MySQL will continue to work as is, right? And this is why we had to enhance and modify the MySQL optimizer so that it understands the Rapid capabilities natively. The second integration we have done is with the storage layer of MySQL. We have enhanced the storage layer so that whenever there is any change which is made to the base table, that change is transparently reflected to the in-memory of the nodes on which the analytic processing is being done, right? So if you have a corpus of tables on which you're performing analytics, if there is any change being made to any of the tables, that change is transparently reflected to the memory of the nodes. As a result, when you have any analytic query which is executed on the service, the changes which were made are reflected transparently. This is one of the very big advantages of this service compared to any other system right now, which does not provide this capability. So as I mentioned in the past, MySQL is a very popular database for transactional processing. People have the choice of using some existing technology, but then you end up with two different systems. One for OLTP, which is MySQL, one for analytics, which could be something else. But with this technology now, all the data stays in MySQL. All the processing can be done with one database, which is MySQL. The main reason for doing this is because we want to provide very good performance. So let's look at how is the performance. Now, the performance depends upon the query, which depends upon a whole bunch of factors. What are the constructs which are being used? What is the selectivity? And a whole bunch of things. So we decided to use a standard benchmark so that there is no contention about whether the query is something which is more or less favorable. So we're using the TPCH benchmark, which is a standard benchmark for analytics. And we'll start off showing the comparison on a single node with half a terabyte of data and comparing it with MySQL 8.0. So on a single node, 512 gigabytes of data. For the queries which we offload, which is around half of the TPCS data set, the performance improvement over 8.0 is 400 times, not 400%, 400 times faster than the current MySQL 8.0. The second thing which we want to show is the scale factor. As I said, it's extremely important to make sure that as you scale out to a larger number of nodes, you have a good scale factor. So we have been able, so we ran the TPCH benchmark again, up to 24 servers, each server having 64 cores. And as you can see, we have a very good scale factor, right? And it is not dipping, so we are pretty confident that it could increase this number even higher. So 24 servers, each server having 64 cores, like a scale factor of about 0.8. When you take these two things, very good performance on a single node, very good scale factor. Now let's see what's the performance on a data set which spans multiple nodes, and let's do a comparison with a popular cloud service, which is RedShift, right? So RedShift is a fairly popular service for SQL analytics. On 2 terabytes of TPCS workload, which requires multiple nodes, both for RedShift as well as for the MySQL analytics, we are 2.7 times faster than the fastest shape of RedShift. So RedShift can be run in 2 shapes. This is the faster of that shape, and the MySQL Analytics service is 2.7 times faster. I haven't even talked about the price, right? I'm just talking about the performance. So if you were to take all the gear you can from RedShift and some limited amount of gear for the MySQL Analytics, it's 2.7 times faster. When we came up with the number of nodes you need for MySQL Analytics, we are optimizing for the price, not for performance. So if you want to get higher number, you could just throw in more number of nodes, and this number would increase from 2.7 to higher. I'm talking about the case when we are optimizing the MySQL Analytics service for the price, we are 2.7 times faster than the best performance of RedShift. Now, so that was about performance. Now, there are a whole bunch of benefits for moving your data from on-prem to the cloud. And we strongly encourage you to move the data because, as I said, the MySQL Analytics service has been optimized for the Oracle Cloud in order to provide very compelling price as well as very compelling performance. But there are use cases where customers have a bunch of data on-prem and they just can't move all of the data into the cloud. So one way by which customers can run analytics on data which is stored on-prem is by using the MySQL replication. So you can replicate data between on-prem and the cloud, and you can replicate the subset of the data on which you want to run analytics, right? So that's one straightforward way by which you can get analytics on data which may be stored on-prem. In addition, we are working on another very interesting capability, which we call analytic departments. What you can do, and again, this is just using the standard MySQL replication, you can decide to replicate a subset of the data on a department and a different subset of data on another department. And then you can run analytics with different number of nodes on each of these 2 departments. So what this enables you to do are 2 things. Workload isolation, so the data which is in department 1 is not visible to the customers of department 2. So you're getting workload isolation, plus you get the ability of having different SLA across departments. No other system lets you do this, right? Workload isolation as well as different SLAs, all within the same instance of the service. So the thing which I want to emphasize is that the MySQL Analytics service is completely integrated with the MySQL service, and this is visible across all fronts. When you start off just looking at the platform, it's a single management platform. You use the same management, whether you're coming through the console or you're coming through the REST API. The same management for managing the MySQL service as well as the MySQL Analytics service. Second, it's the same MySQL engine. We have enhanced the MySQL server to support analytics, but it's the same server, it's the same engine for running both OLTP as well as analytics. And finally, it's the same storage. There is no data movement involved. The data is not siloed. It eliminates the need of ETL. And as Thomas was mentioning, this is all a managed service. You get the management. This is something which is going to be managed by Oracle, by the MySQL team. Same team is managing both the services. This is something which you cannot get from any other offering, whether it's cloud or whether it's on-prem for analytics. This is the only one which will provide you all these benefits. The next thing I want to talk about is some of the work which we are doing as a part of our research for automating various aspects of the MySQL as well as the MySQL Analytics service. All the automation which we are doing is based on a common machine learning framework which is being developed in Oracle Labs. So this is not a rule-based approach. This is based on machine learning. So it's going to take us some time, but once we get it, it's going to work much better than any other existing offering. So there's a common machine learning infrastructure which we are working on in labs. And on top of that, there are 3 different focuses we have. The first one is to model the capacity for analytics. As I said, our analytics engine is an in-memory engine. So we are working on modeling the capacity that is needed for analytics. Second is we are working on modeling the performance of the analytic processing. And the third one is we are working on modeling the performance of MySQL. So we have these 3 different efforts going on. And on top of that, this will enable us to provide a whole bunch of services in terms of the automation. For instance, auto provisioning, auto data placement, auto configuration, and auto indexing. So this is just our research roadmap, so please don't think that these services are coming out in V1. But what I'm going to do today is talk in a little more detail about 2 specific things, auto provisioning as well as auto configuration. When the data from MySQL is loaded into the memory of MySQL Analytics, we compress the data and we encode the data. And the reason we do that is because it leads to much better performance, right? So you have, say, a terabyte of data. When the terabyte of data on disk is loaded in memory of the MySQL Analytics, it takes a very small fraction of that space, right? So let's assume it's about 3x compression we get. Not just that, depending upon the data size, customers may want to have support for multiple nodes. And the reason you may want to have multiple nodes is because the amount of data may not fit into one node, or you may just want to have more compute to accelerate your queries, right? In either case, the question becomes that you have a certain amount of data, how many nodes do you need? If you go to any of the existing services right now, or at least some of the more popular services, offer on-prem, you as a customer have to determine how many nodes are needed, right? And you kind of have that number, and then you're stuck with it. So the problem we have is, how do we determine what is the right cluster size? The answer is, the right cluster size is a function of multiple things. The size of the tables, the kind of the number of columns you want to load, what is the compression factor which you're going to get, and this is something which is not easy to do. So on the left-hand side, you see what is the traditional mechanism people have used for provisioning. The traditional mechanism is the user or the DBA is asked to analyze the table. The user or the DBA takes a guess that, okay, it's 1 terabyte of data. My intuition is it'll do like a 3x compression, whatever the case may be. They start off with some initial number, and then they have to iterate over it, right? And there's a very good chance that either you're overestimating or you're underestimating the number of nodes needed, and either one has a problem. With auto provisioning, the user just asks the auto provisioning advisor, for this data set, how many nodes do you need? Or how many nodes should I provision? And we get the answer right away. Not just that, as the data changes, the system keeps maintaining that information so that at some point the system will tell you that, okay, now it's time for you to increase or reduce the number of nodes. So we are working on integrating this with the MySQL Analytics service. And what this table shows you over here, this is a mock UI we have come up with, is once you have the data in the MySQL service, you will get a screen like this, which shows all the tables which have been loaded into MySQL. The users can then pick the tables on which they want to run analytics, and it may be the case that they just want to run analytics on a subset of the columns, and that's fine too. Once that is done, the system automatically tells you how many nodes are needed for provisioning based on the shape you would like. Right now we're supporting one shape. In the future we may support multiple shapes, but the system automatically gives you some number. Now, many of the times, people may just wonder, hey, how did I come up with this number? So not only do we give you a number, we also give you a mechanism to provide some basic explanations. So for instance, a terabyte of a base table may translate to a different number of nodes depending upon the compression which has been obtained. So what the user or the application can do is that it can go to the informations column, and that column provides you information as to why did we come up or how did we come up with this number. A good example is it could be based on the cardinality. Right? So the cardinality has a big impact in terms of the compression we do. So not only is the system something which automatically tells you what is the expected memory footprint, but also gives you an explanation. So we have tried running this on a whole variety of data sets, and what is interesting is that our accuracy is 5%. So within 5%, for a given corpus of data, we can tell you how much of memory will be taken. And here is the other interesting thing. We are not scanning the data. We don't even request the customers to analyze. We are just able to do this thing based on sampling. So we have an internal API by which we sample some set of rows. Just based on sampling, we are able to come up with something which is 5% accurate, right? So no analyze needed, and we are not scanning through the data. So this is something which I believe is very compelling. No other system provides this capability. And this is all based on machine learning. So when I say 5%, it's 5% accuracy based on the machine learning prediction we are making. The second feature I want to talk about, which is work in progress, is auto configuration. And this is something which is going to be useful both for the MySQL service as well as the MySQL Analytics service. And this is something I'm sure most of you are familiar with. For a given system, right, a given shape, for a given workload, users always struggle to figure out which are the right configuration parameters which should be set and what should their value be. And this is something users or DBAs have to do for each workload. And more importantly, as the workload changes, people usually don't go and reconfigure the parameters. So most of the times, systems are running with some suboptimal configuration, in spite of doing all this hard work of trying to determine the configuration manually. Instead, with the auto configuration approach, the idea is that we have an auto configuration manager. You provide it at the workload, and it'll spit out two things. One is a list of parameters which should be tuned. Secondly, what is the value of the parameters? It's not just that. Once you have the system running, if the workload changes over time, the system will make a recommendation saying, hey, it's time for you to change this configuration parameter, and this should be the value. So a very good example is when people have an OLTP system running. So let's assume you have a system which has both OLTP and analytic needs. You may start with a system which is more towards OLTP, and there may be some set of configuration parameters. But as the workload changes or evolves, there may be a need to retune the system. Currently, it is just not done. With auto configuration, this is something which will be very feasible. This is, again, something which we are doing based on machine learning. And I would say we are still in fairly early research. What we have been able to do is that with the machine learning models we have, for OLTP workload, we tried using sys, bench, TPCC. And for that, we were able to improve the throughput of the TPCC workload anywhere from 30% to 80% compared to the default parameters, right? So what we are comparing with is you have default parameters, you have an OLTP workload like TPCC, and then we use the auto configuration. Using the auto configuration, there was an improvement in the throughput between anywhere from 30% to 80%. So if you look at a cloud service, we are really talking about reducing your cost by 30 to 80%. The improvement was 30% for the cases when the system was less utilized, when there were like resources which were like not completely utilized. 80% was the improvement when you had high concurrency, which is intuitive, right? So if you have more resource contention, if your system is very heavy utilized, then tuning the system will make a bigger difference. And that's why this range. But in a service model, what you have to realize is improvement in performance directly translates to cost, because if your system is faster, you will take less time, and typically you are paying by the hour or by the minute or by the day, and that's why it translates to direct improvement in your margins or the cost. So to wrap up, I want to kind of reiterate the value propositions of the MySQL Analytics service. The first thing is it's something which is natively integrated with MySQL. It's a single system which provides support both for transactional processing and analytic processing. By doing that, not only do we support both, but we now provide support for real-time analytics. So any changes which are made to your old TP system will be reflected in the subsequent queries which are run for analytics. Second thing is the system has been optimized for performance, and specifically we have in-memory performance, in-memory analytics, and the system is very scalable. Since the system is very scalable, the larger the system is, the better performance per dollar you get compared to any other system. It's been optimized for Oracle Cloud Infrastructure Gen 2, again, with the reason of getting the best performance and the best cost. The system is very flexible, and like I did not go into the details of some of that, but the reason this is a lot more flexible than other systems is that one of the reasons is we have completely decoupled storage with compute. Other thing is, as I mentioned, we have the support for analytic departments, where within a single instance, we can provide workload isolation as well as different SLAs. And finally, we are working on a whole bunch of features for automating various aspects of the service, and all this automation is based on machine learning. So if you would like to get more details on this service, we have 4 talks rest of the week. Some of the talks are by our customers who have had a chance to try out this service, and some of the talks are by the engineering team, which is working on this. We also have booth at the demo grounds, so if you would like to get a look and feel of the service, you're welcome to go to the demo grounds. And finally, we would very much welcome any participation or collaboration you would like to have for you to try out this service, which is in beta. And you can either reach out to any one of us, or you can contact Mandy Pang, who is the product manager for the service. And now I'll be very happy to introduce Kajiyama-san, who will be talking about the experience Mercari has had in trying the analytics service. So Kajiyama-san, welcome. Thank you.
Thanks. All right. Hi, everyone. So today I'm talking on behalf of a customer. The customer, Mercari, is a Japanese company, but the guy is supposed to speak for the presentation arriving here tomorrow. So before going to actual slides, one of the most important things is Wednesday, 6 p.m. Wednesday, 6 p.m., Mr. Sasaki of Mercari is coming to be the speaker of his presentation. So today I will just go brief overview of his presentation, but for more details. Yes, it's the beginning of a session, but I'm talking for more details. Please join our session on Wednesday, 6 p.m., third floor of this building, and you will love to see the results of their test with MySQL Analytics service. I'd like to start with who are Mercari. The Mercari is Japanese first unicorn. They already listed Stock Exchange of Tokyo, but they are running their C2C marketplace business. They started their business in 2013, not many years since then, but they are one of the largest marketplace of Japan. It's similar to eBay in US, but they're really popular among younger generations, and more transactions we see every single day. So Mercari is a C2C marketplace, mainly designed for the mobile applications. People take picture of their products or things you want to sell, and a couple steps, it will be uploaded, and people can sell and buy on the mobile phone immediately. To use this service, it's free to use, and there are 10% of our commission of sold price. But another important thing is their service must be really secure. There are many reasons. People can try to attempt to sell fake products, or there can be some kind of fraud as well. So their system must be ready to detecting those fraud or picking up fake products by scanning the information when people are uploading things, or pictures and those descriptions. That requires a lot of analytics operations. It's mainly for the security reason, but also for their business reason as well. By the way, they're running a business not only in Japan, they also have the branch already in US. And they're running a business already in US, and it's getting more and more active users nowadays. So if you're not familiar with it, please search this company's name, Mercari. You see the logo. By the way, Japanese version, a logo of a Japanese version and the US version is slightly different, but also same companies. So let's go look into more about the relationship between their business and MySQL analytics service. They have a really unique policy, data democratization. All employees of Mercari must be ready to analyze data for different purpose, but for the promotion division, business operations, any reasons, of course including security, but again, all employees. And they're educated to writing SQL statements and running on their production database, MySQL. Well, not 100% production data. They must filter personal information. So they have the original filter to filtering the personal information and pushing to the another MySQL server. And the MySQL server is a main database for production operation as well as data analysis. But in some case, unfortunately, as Nippon also mentioned, MySQL is not fully designed for the data analytics. So some queries can take a long time. You can imagine some queries never comes back. Well, after certain hours, it will come back. But still, can take a long time. So in that case, they are using another data analytics solution from Google using BigQuery. So again, Wednesday, 6 p.m., you gotta remember, if you are using Google BigQuery and having paying for data synchronization, cost of BigQuery, this is a presentation telling you how Mercari is looking into MySQL analytics service for their data analysis. So anyways, so this is a brief overview of architecture. Production is MySQL. It's an on-prem environment. It's a metal server. It should be bare metal server. They're using replication, MySQL replication, having the certain custom filter, and pushing into the anonymous DB. This is an AnonDB. It's an anonymous DB. That's also MySQL running on-prem. They're linking with MySQL and a big Google BigQuery using their custom ETL tool. But here's the pain point. BigQuery is not designed for the transaction operation. This also does not care about the data consistency. And they have a huge ETL tool, ETL operations, sorry, transferring data from one to another, from MySQL to totally different data store, Google BigQuery. And that gives a really tough time for Mercari to maintain it. So this ETL tool, data synchronization between MySQL, this is an anonymous DB, is a MySQL server, regular MySQL running on-prem environment, into Google BigQuery. The big problem they're experiencing more often is data duplication. There's no way to checking data conflicts between MySQL and BigQuery, so that's taking a lot of time of their infrastructure team. So that's why they are looking into MySQL. They want to analyze all the data on MySQL if possible. And then, how about using MySQL Analytics service? Now, operation will be much, much simpler because all they need to connect with MySQL server and MySQL Analytics via replication. You don't have to maintain ETL anymore. Of course, they are running hundreds of MySQL in production, so they are familiar with how to maintain replication. That's the easy thing for them. And just having yet another MySQL running on Oracle Cloud, not at the data center. But that won't be a big problem because they also need to DR configuration with replication anyways. And it's really simplify how to operate the environment. To create table, be ready with MySQL Analytics service. It's really simple. Create table, table name, table information, as usual. At the end, if you're using MySQL user, you're familiar with engine equals InnoDB. But there's a new option you can use with MySQL Analytics service, which is secondary engine. And that's Rapid. Rapid, you already see the presentation in the Nippon's presentation. Or even existing table. So really simply, outer table, existing table, secondary engine equals Rapid, and then data will be propagated to the analytics engine named Rapid, and you can accelerate performance of data analytics far faster. So this will simplify operations, and you don't have to worry about anything about additional data transfer between production database, analytics database, not just regular replication. So here's one of the examples of their benchmark. They tested with actually, by the way, Mercari is one of the world's first company testing MySQL Analytics service. They are testing on their production data. Of course, under NDA, but they shared production data with us, with our environment, and they are actually testing it on the running queries on their production data. Some queries took more than 2 hours on MySQL on their existing current environment. So that's why they prefer to use Google BigQuery. That's what they are doing. And Mercari is investing a large amount of money to Google BigQuery right now. And that's becoming a big problem as well. They may want to use more BigQuery, but cost does not allow them to do. There are lots of things they want to analyze. But now with analytics service, look at the performance enhancements. Analytics service is far faster in this top K query. How about this? It took a long time on MySQL. Actually, this one they gave up to running on the on-prem MySQL. But now with MySQL Analytics service, the performance is much, much better. And most importantly, they don't have to change any of SQL statements. They're using SQL statements as it is, which can run on MySQL, and which works as it is on MySQL Analytics service. In the presentation of Sasaki-san, the site reliability engineer of Mercari, will show you some examples of queries which are written by their business team. Because as I mentioned, Mercari's employees are allowed to, or also they're capable to write SQL statements, but they are not professional in writing SQL statements. They never think about optimization. You can imagine what kind of queries those guys are writing. But no need to optimize the queries. Analytics service will do the job to accelerate the performance of executing those queries. So there are several other queries they have Mercari has tested already. You see the significant enhancement in the performance. Some queries they're running just for the test. So that's a few queries that's not really realistic, but still, it's really important them to test different type of queries because they cannot, even Mercari's DBA team cannot be ready for the queries to receive well-written queries. Some are so messy. So you will see it, what kind of queries they're actually running. So You must be excited to see these results. It looks interesting, but sorry, I don't have enough time to explain more details. Lastly, what is the most important thing for this slide? Wednesday, 6 p.m., okay? You gotta come back. So you will see the more details of how they have tested, how they loved it. So then it's time for me to hand it over to next speaker.
Thank you. Hi, everyone. My name is Rich Steenberg, and I work at WePay. And my job here is to tell you a little bit about WePay's history and our history with MySQL. So let's get going. This is our journey. Back in 2008, we were founded in Boston. Our founders, Rich Averman and Bill Clerico, then drove the company literally in a car across the country and started in California. In 2010, we released our first API. The founder of PHP, the creator of PHP, built our API for us, Rasmus Lurdorf, and that was really the first step to us growing to what we are today. Around 2013 is when we put the risk engine into it, and I think, in my opinion, that's really what changed our company. That let us take us to the next step, distinguished us from the competitors at the time, and we started to grow. That's when the curve started to come up. And from 2013 till about 2016 was the rough period. When I started in 2014, and they called it the champagne effect, when literally what it was is like things were just breaking all over the place. It was kind of crazy. 2017, 2017, we were acquired by JPMorgan Chase, and they acquired us because of our shift from crowdfunding to small and medium businesses around also the 2014 timeframe. And now we're ready for our next steps with Chase. So as part of the Chase family, we have three offerings. Clear is our historic API-based interface. It's an indirect model where our customers are platforms, and then people use the platforms, but then use WePay for payments. Link is our direct business. So these are customers of Chase, and Chase has integrated our APIs. So that's really one of the biggest strategic positions that WePay has within Chase in the small to medium business platform. And Core is for the big guys. They're integrated directly with Chase for payments, but WePay's really sweet API and onboarding experience reduces a lot of friction. Again, a huge value that Chase sees in WePay. And so they use us for oversight and for onboarding for the big guys. So what does this mean for WePay? Well, the scale and distribution of Chase is just enormous. So that's just going to be, the way WePay is positioned within Chase is going to be huge for us. And the headwind for WePay has always been brand. And when you're talking about payments, trust is a huge aspect of payments. You don't want the company to be some fly-by-night firm that's going to go out of business. Also, it's your most sensitive data. You've got credit cards and all this personal information that we heard about before. With Chase's acquisition, that problem with WePay is gone now. I mean, Chase is one of the most trusted brands in the world. And so choosing WePay for payments really isn't that scary anymore. So this is a slide just showing how, like some of our customers and how they authenticate with us. So I'll just move on with that. So I've told you a little bit about the history of WePay. Now I want to talk about MySQL at WePay. And back in 2008, when Rich and Bill drove across the country, literally they put everything into MySQL. There was nothing else, including our application logs. That's just the way they did it. And it was maybe not the best design. And as we started to grow, this design started to show cracks. Today, we're just enormous. We have 250,000 calls per minute. The size of the buffer cache is 700 gig. We have a 23 terabyte database, so it's enormous. It's just enormous. And my team is responsible for making this highly available. So this is a chart showing our growth in terms of terabytes. 2014 is when we really started to take off. This is then the slide that shows the replicas on top of that. So the scale of the first one, and then you have like slave replicas and other replicas for analysis and 6 or 7 different copies of that huge database. You're just getting a sense of the growth, and it's not sustainable. We expect to see huge growth going forward at a much more rapid pace, and this is just an unsustainable curve. It's just not possible. So let's go through some events. We were on MySQL 5.1 back in 2008. In 2012, we went to a MySQL 5.5 Galera cluster. We moved to MHA. This is primarily due to the issues that we were seeing. In our cloud provider, Galera did not work very well. It worked fine in a more on-premise type of situation, but in a cloud where things go bump in the night all the time, and the cluster has to gain quorum, these little bumps in the night were causing significant issues. This is also when I joined. The first day on the job at my company, I walk in the door, and I get acclimated to the company, and I meet my coworkers and the people that I'm working with, the SREs, and at 2 o'clock in the afternoon, the whole company went down. And it was because the HA proxy load balancer was overloaded at the time, and we had to figure it out the very first day. In 2016, we made some improvements to the MySQL cluster. So what we had with Galera was we were able to make changes basically at any time because we had 4 active copies of the database. We were able to shut one down, make changes to it, upgrade the OS, bring it back in, have it rejoin the cluster. When we moved to MHA, we lost that flexibility. We didn't have the same flexibility to do those types of operations. Also, with Galera, if something went bump in the night, we had to wait until somebody got there to fix it. But now, I'm sorry, with Galera, when things went bump in the night, it fixed itself because the node was taken out. But with MHA, we had to do it all ourselves. And then in 2018, this is when we really doubled down in MySQL. Back in 2014, we were really wondering whether MySQL was the right thing for us. We were concerned about its reliability. And then in 2018, that's when we moved to MySQL 5.7. We turned on semi-synchronous replication. We turned on GTIDs, and we put in Orchestrator. And Orchestrator able to handle unplanned events that put us back to where we were with Galera. We were then now able to take care of events as they happened. So what happened there? So we are a monolith, but we are also microservices. And the microservices have been coming, and they're growing, and they're becoming more powerful. What we did there is we took a huge portion of our monolith database and dropped it because it was being served by our microservices. And this is how we're going to survive. This is how we're going to continue. So the microservices that we pay. Like I said, we removed the fraud system from the monolith databases. We have about 150 microservices. As we're migrating the data out of MySQL, it's not, the microservices can use MySQL as their persistence, but there's other options. My team takes a lot of care in choosing which storage systems we support. And we've made great choices, and I'm happy to say that MySQL is one of those choices that we made, and it's been fantastic for us now that we know how to do it right. So for our microservices, it's not like the monolith. We have a single instance to single DB to single service, so there's a one-to-one-to-one mapping. We're changing that. This is also provided by a cloud provider. We're taking that out, and because we're so good at managing this huge, fast-moving database in the monolith, we're building the same infrastructure for the microservices. This is what it's going to look like. We're just going to use HA proxy for the load balancer. We're looking at proxy SQL. We're also looking at going to MySQL 8 because a lot of the features that Thomas was talking about, I'm very excited about all of the great features that's coming. That's it. So thank you very much.
All right, I think it's my duty to close the session today, so let's see. So I want to thank, well, if Sasaki-san had been here, I would have thanked him, but he's flying here at this moment, so thank you for standing in for him. That was wonderful. And then Rich, thanks again for coming, speaking with us today. I really appreciate it. So I just want to remind you guys of something that we're doing tomorrow evening, the MySQL community reception. Anybody can come along, but we would ask that you register. I think there's a site on mysql.com. Could someone just confirm that? Yes. They're nodding at the back. So please register so we know who you are and we can greet you. But it's going to be an opportunity for you to meet our engineering team. Okay, so the people that actually design, architect, and build MySQL within Thomas's team. So a great opportunity for you to mingle with those guys and ask anything. So it's at 7 o'clock tomorrow evening in the Samovar Tea Lounge. If those of you who were with us last year, it's in exactly the same place. So be really great to see you there tomorrow evening. So thanks for joining us today. I hope it was a worthwhile session for you, and hopefully see you tomorrow evening. Thank you.